All right, so in investigation 3.3, and this has three. Don't worry about the 3.4 combined. Oh, you guys need a worksheet.
I got it.
So we're focusing on cost. How does the cost per person change if a fixed total cost is split among the increasing number of individual payers? For example, have you guys ever gone to a pizza place with your friends and you order a pizza and everyone's going to split it up evenly? Whether you pitch in $2 or $1.50 or the pizza, say there's 8 of you and you get a couple pizzas, it comes out to like 20, $25, and you got to figure out what everybody owes, right? So that's kind of what we're looking at today. So it's pretty much a real life situation, right? Everyone, mostly everyone has experienced something like that, right? Or you go, you go some, I don't know, what's another scenario?
Are you gonna buy a gift for your teacher for Christmas?
Yeah.
Okay.
Yeah, the whole class is pitching on the Christmas present,
Or an end of the year.
Okay. So that's what we're at today. So it asks us to take a look at page 66. So we'll take a look at page 66. So while we do that, we are gonna pause the video.
That's great book.
All right. So we have our table here, right? And it said it's cost $750 from page 66 to rent out the nature center, right? So if 25 students go, what do you think the pattern will be? How do you figure that out, Jamie? Right, 750 divided by 25, which is 30. So if 25 students go, it will cost $30 per person. Now, as the number of students gets bigger, what do you think is going to happen to the cost? Think it's going to decrease? And that kind of makes sense, right? The more people go, the less you got to pay. What about 50? 15, okay. So that cuts it in half almost, doesn't it? What about 75? 10, okay. It's getting lower. What about 100? Yep, so that's $7.50, right? Right, remember here we're talking about money. 125. 6, okay. So $6. 150. $5. 175. What was it? Does it round up or no? So $4.30 if we round it. Okay. We're just getting the idea here. 200. 379. I'm getting 375. If I take 750 and divide it by 200, yeah, it's 3.75. And then 250. $3. So, and again, remember that's what this part here. This is what they told us in the reading, right? If all 250 students go, it's $3 per person. Whoa. Okay. So, was your prediction true? What did the cost do? It decreased as our number of students got bigger. All right. So it says describe the pattern relating the cost per student to the number of students who visit the nature center. So let me kind of start it for you and you can finish it. As the number of students increase, how can I finish that? As the number of students increase, what happens? Andrew. The cost decreases, okay? The cost per student decreases. But we've got to add a little bit more to it. Something very important. Because how can we tell if this is not linear? Linear does what? What does linear have? A constant rate of change, right? Does this have a constant rate of change? This table? No. So we're going to say at a non-constant rate of change. So we're automatically telling them in the description of this pattern that this isn't linear because there's no constant rate of change. You should be writing that. So as the number of students increase, the cost per student decreases at a non-constant rate of change. This is the big deal. So if I were to ask you to write me an equation, what would you tell me? If C was the cost, all right, so the cost per student to the number of students. So if we're finding cost, what would our equation be? 750 over n. And again, I could find the number of students by using the cost. And if I need to, I can also take the number of students times the cost, and that gives me the price of the nature center, like the total fee. All right, so here's what I want you guys to take a few minutes to do, because apparently on this table from a little while back, my table isn't quite complete, so I'm going to draw some lines. So we're going to pause this video. I want you to take the information from the table up in part 1, and I want you to sketch me a graph. All right? Now remember, your number of students goes up by 25, so if you actually put those exact values in on the bottom, you should be able to fit it all in. And then going vertical, your highest number is 30, your lowest number is 3. So think of a range of numbers, because I think you got eight values here, 8 lines going up here. Okay? So how can I fit 30 to 3 within that range if it's going up by 8? All right? So we're going to pause this video and let you make a graph. Let's see what you come up with. All right, so the graph you see is not linear. Well, if we put these points up here, and we'll do it in a different color to make it look pretty here. So 30 is right about here, right? And then 15, close enough. I went by 4s, so again, if you didn't go by 4s, that's okay. We just want to be able to fit our points in the range. 7.5. 6. That should be in the middle, right? 5. I could probably take 4.3 a little closer to. Something like that. Right? Graph looks something like that. So again, as you can see, as the students increase, the cost decreases. Non-constant rate of change. So our description was pretty correct, wasn't it? All right, let's move it on to the back page. So it says find changes in the cost as the number of students increases in the following ways. So if I go back up here to the table, on the back there, they want you to find the cost as the students change from those 3 values, 10 to 20, 100 to 110, and 200 to 210. So we got to do some thinking here, don't we? Because it's 10 on there? Nope. It's 20 on there? Nope. So how are we going to find those values? Well, remember, x times y equals 750, right? So if our number of students is 10, we would take 750 and divide it by 10. What would we get? Huh? 75. So in 10, that's 75, right? What about 20? If you took 750 and divided it by 20, what do you get? Yeah, 37.5. Or 37.50, right? Because this is cost. Well, so if they want to find the change, what's the change from 75 to 37.5? 37.5, right? So from 10 to 20, we literally cut it in half. Okay? Kind of like we got it cut in half from 25 to 50, right? Everyone saw that on the table? All right, what about 100? Well, what's 750 divided by 100? 7.5, right? But 110, I think 100 was on there, right? Yeah, 100 was on there, but 110 isn't. So how do we figure out 110? Right, which is 6.81 repeating. So 6.81. Because again, if we're rounding it to the nearest dollar, right, cent. So what's the difference between 750 to 6.81? It's got to be less than 1, right? That's pretty significant, right? Look at the big change. From 10 to 20 goes down $37.50. But from 100 to 110, we're only decreasing 69 cents per student. That's not a whole lot, is it? All right, so 200. If I took 750 divided by 200, what do I get? 3.75. So see, even though those values are on my table, I can still divide it by the constant, right? What's 3.57? I just gave the answer. What's 750 divided by 210? 3.5. How'd you guess? So what's the difference? This is less than 1. 18 cents. So do you see how the cost per student really, as that number gets higher, it really doesn't save us that much money, does it? I mean, let's be honest though. I mean, paying $3.57 is a whole lot better than paying $37.50, right? But as you can see here, that the drop in cost isn't a ton, especially as these groups really increase significantly, right? So number 2 says, is the function relating the number of students to cost and cost linear? So is this linear at all? No, and again, it's not linear because what? There is no constant rate of change. So this is not linear, no. Because there is no constant rate of change. And we said that on the very beginning, didn't we? The change isn't constant. If the change was constant, that curved line would be straight. And it's not. It's not even close to being straight. And so number 3, it says, so do equal increases in the number of students cause equal decreases in the cost per student? Well, look. Here I went up by 10, right? I go up by 10 students, what's my cost? It went down $37.50, right? Here I go up by 10 students, right? From 100 to 110. What's my cost now? My cost only decreased what? 69 cents. Here I went from 200 to 210, another section of 10, right? So what did my costs decrease by? So it's not equal, is it? No, it's not equal. Okay? It's not even close to being equal. So for number 3, obviously, we just answer no, it's not. It didn't say to explain, but you can see it right from here that these numbers, as we gave you 3 different groups of increase of 10 students, those costs aren't equal. It's not even close. All right, we're gonna take a couple minutes to pause. I want you to read D and see if you and your teammates can come up with an equation for that little scenario down here in part D. Ooh, that's not here. Is it over here? There it goes. That's what I'm looking for, right here. I want you to worry about the graph right now. I just want you to read that little scenario, talk it over with the group, and see if you can come up with an equation. Now again, they want the amount. For the amount A is the teachers will collect of if N students go on the trip. So A and N are your 2 variables. See if you can come up with an equation for that. So we're going to pause this and see what you guys come up with. All right, we seem to get that done pretty quick. So what equations did you come up with? Blake?
Came up with A equals
5 over N? 5N or 5 over N? That's what you first told me. So you think it's 5, just 5N then? It's that. Okay. Do we get anything different? Or did everyone come up with that? Katie? A equals 5N. This? Right there? Any other groups get that? Anyone get anything different than those 2 things? All right, so the scenario reads this. Let's see which equation makes more sense. The science teachers decide to charge $5 per student for the field trip. So it doesn't matter how many people go, right? $5 per person. Where in the previous problem, right, the cost per person changed, right, as if we have more people go. So they'll use any extra money to buy science equipment for the school. So if 5 people go, and I plug that into this equation right here, how much money do we have if 5 people go? 5 over 5 is what? So we would have $1. Does that make sense to the scenario? For here, if I plug in a 5, at $5 per student, what am I getting here? 5 times 5. 25. So it's this equation right here. All right, so now, for you guys on the back page, for me it's below this there, is you got a little graph. I want you to take that equation and graph it. And see what happens. How does D compare to A? How does D compare to A? Come up with a graph and let me know what happens. So N would be your X basically, and A would be your Y if that helps you put it on the graph. So if we go ahead and plot those points, right, at 1 student, $5. 2 students are $10, right? 15, 20. As high as I can go here till I run out of room. And we have a straight line. So the question that's on the bottom there is then, does this graph show a linear or inverse variation? And we all said linear. And why? Because it has a constant rate of change, which is the $5. The graph has a constant rate of change. So you see the difference between part A, which they're going to the Nature Center no matter how many students go, it was $750 to rent it, as opposed to a linear model, okay, comparing linear to inverse variation. See the difference? And not only that, the equation that we came up with, was that even of inverse variation form? It didn't even set up with the inverse variations we did in the front, right? We look on the other page. Right? A equals 5n. Look at the equation we came up with on the front side. Right? So it was even a different equation. Alright, so we're going to stop that here then. That's the end of that video.